Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Connectors serve as the physical interface between network cables and the equipment they support. Whether you're plugging a copper patch cable into a switch or terminating fiber strands in a distribution panel, the type of connector you use directly affects the network's performance, reliability, and maintainability. Properly selected and installed connectors ensure that electrical or optical signals are transmitted cleanly, that the cabling system is modular and upgradable, and that devices from different manufacturers can interoperate without signal loss or damage. In the Network Plus exam, media connectors are a frequent subject. You may be asked to identify connector types in diagrams, match names to visual representations, or determine the correct connector based on a particular use case. Both copper and fiber connectors are covered, and understanding the differences between them, along with where and how each is used, is critical for passing exam questions in the cabling and infrastructure categories. You'll also need to know which connectors are legacy and which are commonly used in modern installations. The most widely used connector in networking is the RJ45. This is the modular 8-position, 8-contact plug used to terminate twisted pair Ethernet cables. RJ45 connectors are compatible with Cat5e, Cat6, Cat6a, and higher-rated cables, and they snap securely into matching jacks found on switches, routers, wall plates, and computers. Each of the 8 conductors inside the cable must be aligned precisely with the pins inside the connector following the TIA/EIA 568A or 568B wiring standard. RJ45 connectors support everything from 10 Mbps Ethernet to multi-gigabit Ethernet speeds, depending on cable quality and installation practices. RJ11 connectors are similar in appearance to RJ45 but are smaller and contain fewer contact positions, typically 4 or 6. These connectors are primarily used for telephone wiring and DSL connections. You'll find them in residential telephony, older modem setups, and sometimes in point-of-sale systems that still use analog signaling. Despite their physical resemblance to RJ45, they are not interchangeable. Plugging an RJ11 into an RJ45 port can damage the pins, and the wiring is not compatible with Ethernet signal. The BNC connector is a bayonet-style connector used with coaxial cabling. It features a twist-lock mechanism that provides a secure and stable physical connection, making it suitable for applications where vibration or motion might dislodge simpler connectors. BNC was used extensively in early Ethernet networks, such as 10BASE-2, but now finds more use in analog video systems, security cameras, and test equipment. Proper impedance matching, typically 50 or 75 ohms depending on the system, is essential when using BNC connectors to avoid signal reflections and data loss. The F-type connector is another coaxial connector, typically threaded for a more secure fit. It is widely used in residential settings for cable television and internet services. Internet service providers often terminate the coaxial drop line from the utility pole or distribution hub into an F-type connector that screws into a cable modem. The modem then converts the signal to Ethernet for use in the home or small business network. While not part of typical enterprise cabling, F-type connectors are still important in broadband access networks. In fiber optic installations, the LC connector is the most common form factor in modern enterprise and data center environments. LC stands for Lucent Connector and features a small form factor with a latch mechanism that makes it easy to insert and remove. LC connectors are favored for high-density patch panels and equipment interfaces because they allow more ports to fit in a limited space. They are used with both single-mode and multi-mode fiber, and most SFP and SFP Plus transceivers are designed to accept LC-terminated cables. The SC connector, or subscriber connector, is another common fiber optic connector. It has a larger square body with a push-pull locking mechanism that offers a satisfying click when fully engaged. SC connectors were once the dominant choice for multi-mode and single-mode fiber networks, but are now slowly being replaced by LC in space-constrained environments They are still widely used in telecommunications rooms, older patch panels, and some media converters. Their larger size makes them easier to work with during initial installation and maintenance. ST connectors, short for straight tip, feature a bayonet-style coupling mechanism that locks into place with a simple twist. ST connectors were commonly used in multi-mode fiber installations in the NINTs and early 2000s, particularly in education and industrial facilities. Although their use has declined in favor of LC and SC, you may still encounter them in legacy networks or in applications where physical vibration is a concern and a twist lock mechanism offers additional security. For ultra-high-speed fiber links, such as 40 Gbps or 100 Gbps data centers, often use MTP or MPO connectors. These are multi-fiber, push-on connectors capable of handling 8, 12, 24, or even more fiber strands within a single connector body. MTP/MPO connectors are essential for parallel optics, where multiple fibers are used simultaneously to transmit and receive signals. Because of their density, these connectors require extremely precise alignment and are usually factory terminated and pre-tested. Special cleaning tools and polarity management are essential to avoid signal degradation. The polishing of a fiber connector end face significantly affects performance. Connectors can be flat polished, ultra polished, up P, or angled polished, up P. UPC connectors have a flat or slightly domed surface that minimizes back reflection. FPC connectors have an 8-degree angled end face that reduces reflected signal even further, making them suitable for long-haul applications or high-precision links. APC connectors are typically color-coded green, while UPC connectors are blue. Mixing the two can result in signal loss and poor connection quality, so matching polish types is as important as matching fiber mode or connector type. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Beyond the cable connectors themselves, modular transceiver modules are a critical part of modern fiber-based and high-speed copper networking. Small form-factor pluggable SFP modules are hot-swappable transceivers that plug into switch, router, or firewall ports to enable connectivity via fiber optic or sometimes copper cables. SFP modules typically accept LC fiber connectors and support various speeds and distances depending on the specific model. For example, an SFP designed for single-mode fiber might support 10 kilometers of reach, while a multi-mode SFP using OM3 fiber may be rated for only a few hundred meters. Matching the correct SFP module to the fiber type and connector is essential for establishing a working link. For higher speed requirements, such as 40 gigabit or 100 gigabit Ethernet, SFP modules are replaced with larger transceivers like QSFP, Quad Small Form Factor Pluggable, or QSFP+. These transceivers support multiple lanes of data and are often used with MPO or MTP connectors that carry multiple fiber strands simultaneously. These connectors are ideal for data center environments where massive amounts of traffic are aggregated and funneled through core switches. QSFP+ modules offer a compact way to deliver high-speed uplinks, and their compatibility with DAC cables or breakout configurations makes them highly flexible for short-range, high-capacity connections. While fiber transceivers are often used in core and distribution layers, copper connectivity still dominates at the access layer, particularly in structured cabling environments. Keystone jacks are modular connectors used in wall plates and patch panels to accept RJ45 plugs from Ethernet cables. These jacks are color-coded to match the TIA/EIA 568A or 568B wiring standards and can be quickly replaced or re-terminated without removing the entire wall plate or panel. Keystone jacks simplify cable management, reduce wear on switch ports, and allow for easy changes during network upgrades or relocations. At the back end of keystone jacks and patch panels, punch-down blocks are used to terminate twisted pair copper wires. The most common punch-down interface in modern Ethernet wiring is the 110 block, which aligns with the TIA/EIA standards for Cat5e, Cat6, and Cat6a cabling. Technicians use a punch-down tool to seat each wire into its appropriate slot, cutting off the excess and ensuring strong electrical contact. Proper technique is vital, as incorrect punches or cross pairs can lead to poor performance or complete signal failure. Punch-down blocks are usually labeled and organized for efficient cable tracing and maintenance. In fiber installations, adapter panels and enclosures provide structured termination points for fiber runs. These panels accept LC, SC, or ST adapters that allow pre-terminated fiber cables to connect through a physical interface. Inside the enclosure, fiber slack is coiled carefully to maintain bend radius requirements and protect the cable from damage. Adapter panels simplify moves, adds, and changes while offering a clean, professional way to manage multiple fiber strands. Many panels include label fields and documentation holders to support accurate port tracking and fast troubleshooting. Connector color coding is an important part of cable and connector management, particularly in high-density environments where many cables and ports are bundled together. In fiber optics, the color of the connector housing often indicates polish type. Blue connectors are typically UPC, ultra-physical contact, used in most enterprise links. Green connectors signify APC, angled physical contact, which are used in high-precision or long-haul environments where reflected light could interfere with sensitive equipment. Yellow jackets often denote single-mode fiber, while orange or aqua jackets indicate multi-mode fiber. Following color coding standards helps prevent mismatches and supports fast identification in both installation and repair scenarios. Cleanliness and inspection are mandatory practices for fiber optic connectors. Even a microscopic speck of dust or oil on the end of a connector can significantly reduce signal quality or prevent a link from establishing at all. Unlike copper connectors, where a dirty contact may cause intermittent issues, dirty fiber connectors can result in complete link failure. Technicians should use lint-free cleaning tools, specialized fiber connector cleaning pens, and inspection scopes before making any fiber connection. Regular cleaning during both installation and maintenance is necessary to ensure optimal optical performance and to prevent damage to expensive transceivers or switch ports. Connector topics appear frequently on the Network Plus exam. You may be shown a photo or diagram of a connector and asked to identify it by name or match it to a cable type. For example, recognizing that an LC connector is used with an SFP module, or that a BNC connector is appropriate for a coaxial cable in a CCTV system. You may also be asked to choose the right connector based on application, such as identifying the best fit for high-density data center equipment or matching connector types to appropriate network speeds. These questions test your familiarity with both modern and legacy equipment. And understanding connectors is not just about naming them. It's about knowing how they function in the broader network. A poorly crimped RJ45 plug can lead to performance issues in copper links. An improperly cleaned LC connector can prevent an entire switch uplink from coming online. Mixing UPC and APC connectors can introduce reflection that degrades a signal over distance. Misidentifying a QSFP transceiver can result in buying the wrong cable type for a switch uplink. These details can impact everything from performance to cost and troubleshooting time. In summary, both fiber and copper connectors are essential to network functionality. They serve as the bridge between transmission media and equipment and play a crucial role in the overall design, speed, and scalability of a network. Mastering their names, physical characteristics, use cases, and maintenance requirements is critical for exam success and real-world network deployment. Whether you are managing structured cabling in an office, deploying fiber in a data center, or selecting transceivers for a new switch, understanding these connectors ensures your network is built to perform reliably and efficiently. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.